Well, it all started when I was about 6 years old. I designed my first circuit. I got a hold of a cord and a plug, AC plug, and I connected a light bulb socket with a light bulb in it and a knife switch, as you see on the top here. See, I don't know how that works. That's not working. Okay. And I plugged it in, and then I threw the light came on. I threw the knife switch, closed the knife switch. Hey, the light went off. Why'd the light go off? Well, I learned I had crossed the lower, went across the load and blown a fuse. Okay. So I learned a lot, really, because you can learn a lot by your mistakes. I learned that you don't go across the load, number one. I learned parallel and series circuits, a little bit of definition. But most important, I learned that after 3 fuses, grandma gets mad. So as I was still young and so forth, growing up, there was no computers at that time. So my interest kind of shifted from electrical circuits to radio. At that time, everybody that was interested was building crystal sets. And I built a lot of those crystal sets, and they were pretty easy. You can see here, you get a hold of an old Ford coil, and you can wind that on a oatmeal carton and make a tuner out of it with frequencies, okay? And you have a crystal here, and what happens is you hit the right frequency of a certain radio station, and you could hear it through your headphones. I graduated to TRF radios, tuned radio frequency, which preceded superettes that we have today. And they were pretty simple, but they still had about 4 or 5 tubes in them. And I unsoldered, took apart a complete radio and made a hand schematic of where it would go back, and then soldered everything back together. And lo and behold, it worked. Oh, it's a wonder. So then I grew up. Did get to radio shop also in high school and senior year. They started that, which was good. I went in the Air Force, and I went to radar school in Mississippi. And I'll show you what I learned there. I had about a year in Mississippi there. And then shipped out to France. Had 3 years in France and went to a school, microwave school, because in France, and learned to repair. And the rest of the time I was in France, I was repairing, keeping maintenance on the base-to-base communications microwave. Okay, while I was there, I didn't play all the time or work all the time, but I did take some USAFI and ECI courses on electrical design and TV repair. My intention was really, when I got out of the service, I was going to open up my own TV repair shop. And again, the computers, didn't know anything about them. They had started, but I didn't have anything to do with computers at that point. While I was in Keesler in radar school, we'd had about 2 or 3 months of just pure theory, nothing but theory. And so this one instructor, he was going to give us a demo, which is great. And what he did is he made a waveguide out of 2 large wires, okay, side by side, connected up a signal generator and set it to a frequency that would produce a standing wave on the waveguide. All, standing wave, we've been taught theory about that. That's great. Then he took a vacuum tube voltmeter and he drug it along the the waveguide, and the thing went up and back down. But it was just an event that I'll never forget. We gasped. We said, stuff really works. Great. While I was in France, I was in 8th Radio Relay, and I was tuning a Clashtron. We had Clasztrons for our transmitter part of the microwaves. And we had 2 units sitting side by side, as you can see here. And one night I'm tuning the Clashtron, and I'm looking at this standby unit, which was powered down completely, no power. And the meter here was going, following my tuning of the Clashtron. And I never did quite figure it out, but I think what was happening was the RF in the waveguide was somehow getting to the leads to the meter. Of course, we had individual components in the old days. These were resistors, and we had a color code which dictated what the value of the resistor was on each resistor. So if you knew the color code, you could figure out how many ohms resistance that resistor had. And we had a way of memorizing that, which was in the colors sequentially went, 0 through 9, and it was bad boys rape our young girls, but Violet gives willingly. So you can see here that you've got green, red, and black, which equates to the numbers 820, or these resistors were 820 ohms. Likewise, we had a way to memorize some other electrical design functions. We had one called Eli the Iceman, which meant E means voltage, and L means induction, and I means current, and C means capacity. So Eli is in an inductance circuit, voltage leads current, whereas in a capacity circuit, it's just the opposite, current leads voltage. And we had little things like milliwatt and microhenry rode his megacycle across the Wheatstone Bridge, stuff like that. I got out of the service, excuse me, and my first job was with Martin Company on what was called a Missile Master. And Missile Masters was a air defense system manned by Army, and of course Martin created it, and we were out there as tech reps guiding the Army, showing them how to maintain the system. My first job was in Seattle Air Defense, maintaining that air defense system. And I got drafted for the Birdie, which was a transistorized version of Missile Master, much smaller, compact. And then after I taught there for about 10 classes, about a year, the pick of the Army. And the first class was pretty good. We had warrant officers and pretty sharp people. By the time we got to class 10, we had cooks and people out of the motor pool, and maybe not so good. Anyway, we had to test this thing. So up in Connecticut, I was the manager of testing for the proof of concept for using simulated targets and the 4 Nike units in Connecticut. Then I was sent to Kansas City defense area, and I had 2 incidents there that were pretty interesting. One was our communications. We provide communications to SAGE, of course, 2-way, and it kept dropping out intermittently, maybe once every 2 weeks or 3 weeks. And it took a couple months to find this one. And what it was if the height finder at the battery, Army battery, was positioned at a certain angle towards the FOOF van, which is a communication van, and the van's door was open. And then the height finder would go in, bap, and wipe out the communications. That was a hard one. And then one day, every day in those days, you had one of the batteries would be responsible, would be called the hot battery. And the Air Force would try to integrate the defense area without the Army knowing. The Army on the ground would be responsible, the hot battery, for locking on, detecting and locking on that aircraft. And the Army was winning every day. And one day we're in the van watching the radar scope, PPI, and we see this blip. Woo! And it's in and out of our defense area and on to Omaha before we could even think of locking on. And what it turned out to be is one of the initial flights of the B-58 Hustler. So that was kind of an interesting part of history. Here's a block diagram or conceptual diagram of the Missile Master itself. And as you can see, we had communications to and from SAGE, and we had our own radars, and then we communicated to the fire units. Yeah, they had Nike, Ajax, and Hercules missiles. Inside the Missile Master, they called this the Blue Room, and it was because it was dark and blue, so the operators could see the screens really good. We had one operator down here who was called the Friendly Protector, and if a tracker locked on one of our own aircraft, this Friendly Protector was there to tell him to unlock. And some people said, well, he'll draw his .45 and shoot the tracker. Inside, we had all this equipment. Again, in this particular time frame, we had vacuum tubes. Were doing was our main fast memory, although it wasn't that fast. And long-term memory was latching relays, really old-fashioned. Here's a Nike Army Nike battery, and you can see the missiles there. Here's inside a Birdie, okay, the van, which is a lot. You had one or two operators, I think, and on the Birdie, rather than all those operators you saw in the Missile Master. SAGE itself was pretty good, and of course it's connected to North America, to some of our defense up there with the bombers and so forth. It had a DC direction center, had like 50,000 vacuum tubes. And I was on tour one time, and I remember the guide telling us one stat was, if you turned off the air conditioning to the equipment and left the equipment on, everybody would fry within 7 minutes. Then I went to work for a commercial side. I got out of the military type thing, and went to work for TRW, which was the first in many fields, first in oil refineries, first in steel mills, first in television commercial switching, a lot of that. In fact, when we started, we had the TRW 330 computer, which was we had no core at that time. It was drum stored. Everything's stored on a drum, rotating drum. And I went to CBS, New York City, to maintain two computers that were doing commercial switching for CBS. And of course, when I got there, the union said, hey, anything that's got a cable in this city we own, we're going to cable it up. And as a good tech rep, I wouldn't allow those monkeys to touch my machine. So we went round and round, and finally the guy said, okay, we'll have one of our union guys sit there and watch you, okay? And of course, they collected double time and all that. About 2 o'clock at night, I'm not done. I got 2 computers to bring up. The guy says, "Hey, man, I topped out, man. I don't get any money. You don't anymore." I said, "Leave, man." And then I had I know this was paper tape reader was loading the daily switching program, okay, basically. And at nighttime, the reader was going out. So I finally found that problem. It was pretty intermittent too. And what happened is they didn't have tech power to the reader. They had just regular power, and on the other side of the wall where the reader was, janitor would come along, plug in the buffer, take it down. That's also a time that up to that time I'd been really on the hardware side, maintaining hardware, field service like that, in my jobs and in the service. And we had a software problem. So the programmer came out, and he's sitting there for an hour, 2 hours. "What are you doing?" "I'm assembling." Another hour. "What are you doing now?" "I'm still assembling." He's drinking coffee. But then he really impressed me, because then what happened was we had a problem where I had kind of an intermittent, and he says, "Do you have a scope with delayed sweep?" Man, I'm impressed. This is a programmer that knows about delayed sweep on an oscilloscope. So I get it for him, and he goes down to a like 6 stage of a divide or whatever, and he says, "See this bit here? It's missing. It's not coming in." And I changed the card, and we're in business. So I said, right there, maybe software is not too bad of a thing to do. Here's an early drum computer, and these things take like 16.4 milliseconds for a revolution. So if you wanted to optimize your code, your program, what you had to do is figure out how long the instruction you were executing would take, and then you would put the next instruction address at a sector just after that amount of time. Well, after Bunker Ramo, I went to work for Scientific Data Systems, which really was eating IBM's lunch as far as scientific systems went, the computer manufacturer. And I was still in hardware at that time, and I for about a year and a half, I stayed in engineering design. But about that same time, I always wanted to do design. I always knew that design was my thing. And design became much less challenging because everything got integrated into cards and so forth. And as far as field service, you no longer isolated anything to a component level. You just picked a card and changed the card. As far as design, it got catalyzed. It got so that you had a book that of shift registers and control systems and so forth, and you'd pick out what you want and then figure out the loads between the two. So a lot less challenging. So I was not really happy at that point because I'm not getting as much design. So I became a diagnostic programmer. I went into that. And of course, my first challenge was mag tapes. I did that. And from that time on, I knew that was the world I wanted to be in. I wanted to be in software. Same time, I started going to UCLA, and they had a computer course at nights that would cover operating systems and communications and all kinds of wonderful things. And I got a certificate in that from UCLA, finished that. While I was at STS, I developed or helped develop what they call the MagPack, which was one of the early small magnetic tapes used for computers. And SDS, when I got there, they had the 900 series, which was more or less like an outgrown uh, mini computer, but a little heftier. And as I worked at SDS, they developed the Sigma line, Sigma computers, which was their answer to the IBM 360s, and they all had to be compatible. Here's Sigma 7, the biggest one, with a lot of their MagTape units and a lot of their disk units. After SDS, because they moved, Xerox acquired them and they moved south, and I was already driving 40 miles on the freeway in LA, and I don't want to go 70. So I quit and went to work for Litton Industries, which is a military contractor. And first job was on as a programmer on an early spy plane project. It was the AWACS's predecessor, called College Eye. And my job was computer fault isolation. And as a young programmer, I thought, wow, this is really great. What you had to do is assume the computer was, excuse me, completely down, and then you had to maintain control and operability, and you built up the operability, saying, hey, the adder works, so memory works, and so forth, until you found the fault, okay, and then you turned on 107 lights for that particular card. And later on, of course, as I matured and got a little older, I said, that wasn't really great. I could have changed the cards 5 times and found the problem, okay? But anyway, one of the other things I thought was really fun was real-time collection. I did a project because we wanted to see what program was taking the most time, real time. And as it turned out, it was navigation. So here's the military computer we worked on was the Litton L304, and here's the 7 cards with their little lights. Okay, the applications were tracking, guidance, display, reports, and navigation. Then I went to a little software company and did some programming. My assignment was steam plant. This was California Edison, and GE had supplied the computers, and since then they were old computers, drum stored program computers. And GE said, hey, look, we'll give you new computers, 225s, whatever. And if you know utilities, no, utilities say, I want what I bought, period. And that's what they wanted. So our job was to streamline it a little bit and open the loop. In other words, we put the operator in command instead of a closed loop type system. So I learned a little bit about steam plants. Beautiful things. What does a programmer do, basically? Well, a programmer designs the specifications and creates a flow chart, and then he codes to that flow chart and integrates it into the system, and then checks it out and supports that. I then went back to Litton, only a different division. This was Environmental Systems Division, and became manager of programming there. And their main thing was air pollution systems. And I remember the 9 months we worked on LA system. We had to raise the alarm condition in Pomona a couple times so we didn't panic the people. You don't know what goes on. And then we had California Aqueduct Control Systems, pumping plants, which was great. California, these state agencies are tough customers because they write a spec with liquidated damages and so forth. And that's why eventually Litton decided to close this division and get out of that game. But the California Aqueduct actually ran 600 miles. And what they do is they stop at they'd be at the top of a mountain, and they would run down 1 foot a mile till they got to the bottom of the mountain, and then they put a pumping plant in to go back up the next mountain. We had one site called A.D. Edmondson that was really big. It pumped up just shy of 2,000 feet and had 80,000 horsepower motors on it. And then we had conventions like electrical storage, where you might create a lake and run that lake down through a hydroelectric generating plant during peak power time, and then at night, off peak power, it pump the water back up into the lake. So what happened? Litton closed their division, and I took the programmers with me that I had working for me and started a business. So I think one thing you might learn here, they don't all work out. This one did. We lasted for like 6 years. Missed on a couple of big bids. You got to really keep the bids going, I think, is another lesson. And then we were out of business after that 6 years, but it was a good time. During which we developed the control systems for most of the pumping plants on the aqueduct. We also developed some earthquake acquisition software development, and some basic process control system software, which included a few things like that, steam plants. Here's a picture of A.D. Edmondson, and you can see behind them, this is the forebay coming in, and then the penstocks are buried here. They were like, 2 giant penstocks went up this hill of 10-foot radius, okay, each. There's the control room. And during that time, we didn't really have ASRs or teletypes or Selectrics or any of that. So we depended on, as far as input-output control, we depended on LEDs here and matrix, switches for inputs. Another output device was a MMIC here, which showed the flow of the electricity in the plant and also the flow of the water. Back here is a mini computer, the Honeywell 316 that we used. We had a team effort where there was 4 of us on that aqueduct project. The 4th one is taking the picture here. And we did a bike ride where 2 of us started from one of the plants, and then upstream or downstream, whatever, the other 2 started, and we met in the middle of the desert there. Well, after ESD closed, I did go to work for DSD again, which was the first Litton I had worked for. And I worked for, there was a NATO defense contract development, and my chore was executive, develop the executive, the disk optimization, and the computer communications. And we were using TACPOL at that point, which is like PL1. At the same time, I'm at Litton there. I'm studying. I'm still studying. I think I studied all my life, and you have to, especially in IT. And so I'm studying besides working. Then we had Christmas parties. They always have Christmas parties, big companies, and at that time we had you'd go to a Christmas party. We were all pretty young families working, and normally you'd start talking to other families, and you'd come out with pictures, okay, of your kids, their kids, and all that. And I had a guy that I worked with there that had made a computer and put on a CRT the eyes that would go back and forth, and made a paper hand. And it was quite a challenge because the computer he did it on was what's called a Chem 1, had only 256 bytes of memory, so you don't have a lot. Uh, and of course, he showed his pictures that he showed was of Chem 1. While we were at Lytton, the chip manufacturers like Intel came out with what we call microcomputer kits, which were affordable, and they were pretty minimum, but you could program them. You had two 128 byte chips here, which gave you a total of the 256. And you had the 8085 here. You had a LED display. You had a keyboard. Okay, so you could do a few things with that. Here's Chem 1 that Stan had used, and they added a little I/O port here that allowed you to store and retrieve data off of a cassette tape recorder. So you can see he was kind of strapped on what he did, but he accomplished quite a bit. And again, if you really have an interest in a job, you get the right job, you don't mind putting some extra time in. And that's what you should be doing. Okay, then went to work for. Well, I started a job and got kind of backed. I found a mentor, a good mentor, and this is a thing you ought to really concentrate on, is looking for opportunity, of course, but getting a mentor. A mentor really turns up opportunities for us. And he had a company called Image Resources, and I had moved to Arizona at that time and started my second company called SGA2, whatever. And basically what we did is we did development. We developed an automated computer-driven signage system. Okay, and I got a couple of patents on that, and for the first signage generator system, and also developed some pretty good graphic software for and presentation graphics on a digital film recorder. Time went along, and of course Image Resource acquired us, and the mistake I made there was selling the company for not enough money, basically. So you should be aware of that. The other mistake is once you sell a company, you've got to realize you no longer have control of marketing. And they got acquired by a big company called Calcomp, who didn't want us to do any marketing. As a result, when technology kind of made an end run on us, the signage thing, of course, fonts were not magic anymore. You could use Word to make signs. Slides, you didn't need slides because now they were outputting directly from things like project, or like this, project out directly, so you don't need slides. So you gotta keep marketing. Same lesson. Okay, here was it was the crew, some of the crew. We got up to 16 people, but we were up in a small town, Arizona, and we had a good life. We had good technical challenge, and I had mainly they were programmers, except for Dougie here, who was a graphic design guy, and he was good. He generated all the icons and fonts and all of that. Here's the first signage system, and that was our first plotter. It was the Versatech. And there I am on the system. We had this, it was continuous paper off of the plotter. So we had this thing called the guillotine that cut the paper, and it was dangerous. You had to Keep away from that dog. Okay, so now we did some additional things just to kind of get our exercise and get in with the printers and so forth. And one was selling signs and banners. This is my daughter. Here's my main mentor I found, John Cool, and we had him up here for picnic, and we were awarding the first sign that came out. And kerning was terrible, but it was generous. It worked. Here's my granddaughter, one of my granddaughters. Okay, here's the Samurai film recorder. And then these other things are called video printers, okay, which were strictly all analog, but taking pictures of things like satellites and so forth. But this was generating slides. This gal, I can't think of her name now, but she became famous in Hollywood, actress and all of that. This was a younger time. Okay, here's some of the output of our film recorder. There's my granddaughter again, and my daughter. And here's a pie chart on IBM PC. Okay, and we could do 16,384 colors. Okay, along with that time, we did some promotional product shows to sell units and so forth. I think this was in San Francisco. That's my wife, and we had I had a good little booth there. We dressed up, and of course, the name of our film recorder was a Samurai, to fly in the face of the Japanese, but built in the United States. So we dressed up like samurais. I looked more like an Indian, they told me. Okay, here's another promotional thing. We're system generation. Column chart. Another pie chart. And we did other video projects too. Jumbo chart. We figured, oh, we could scale our output to anything we wanted to most printers, okay? So, hey, great idea. Why, if we could create a market for courts, okay? People doing in courts, they could make big charts explaining their argument and so forth. And we mailed 4,000 brochures out. It got zero response. Okay. And I went to work for a company called Equinox and manage a large group. We were going to do development, or we did development on site in Korea. And believe me, that was an effort. I must have reviewed over 100 people, so I got a lot of experience looking at resumes, talking to people. And we were located in not too great of an area in Pacoima, California, which is, as I say, it's a dangerous area. And I'm interviewing this one particular kid at night, and he's walking out. He was a good programmer. I wanted him. And the guard says, "Where did you park, sir?" And he says, "Oh, right over there by the apartments." and and the guard says, "Oh my God. Okay, well, try to get in your car. If you get attacked, we'll call the police." That guy never called back. And that apartment complex had the highest homicide rate in LA County. Okay. Koreans, it was a good experience in Korea. Really liked the South Koreans. They excel at negotiation and celebration. After that, I went to support Ann Taylor in Louisville. Okay, here's the Korean project. We're up on what they call building 82, which was the highest building in Seoul. And that's Mr. Kim, one of the top managers in Samsung, and his wife, and my wife, and me. And then we're having meetings with the Koreans. And some of the meetings, they learned because they are very courteous people. But when we first got there, I had a lot of different people, and I had American Koreans. I had 4 or 5 of them on the project, and what the Samsung, the client did is they gave them cell phones. I said, no, no. So they backed that off. And they also started talking Hangul, their own language, in the meetings, and told them that doesn't wash either. But they are, as I said, they are very courteous. When they find out there's something you don't like, they'll change it. Here's the big building, and it was a vertical warehouse, which you never hear of. 6 stories, a lot of railing, automatic railing. And here we are at dinner, having fun, having fun. This guy's an Iranian, this guy's a Dutchman, these guys are Americans, and these guys are Koreans. So we had a good mixture. Same thing. Here's an Indian and American Koreans. That's my birthday party. And Marty. I worked with these 2 guys most of the time. They were great. Really great. Here's a carton sorter. We had about 3 of those there. And one time we went to Korean's version of Disneyland. And this little guy thought we were at Disneyland in America. And then my wife got to Korea, and because she had a friend that her husband was in the Air Force, and he was down at Osan. So she got there. Mr. Kim and his wife took us out to the Yellow Sea at a picnic. That was good. I ran a race while I was there in the Sarak Mountains, and that was pretty interesting. We got there, and we didn't know why all the Koreans. There was 40 of us internationals or honkies, and 1,100 Koreans, and we didn't know why they had boots on. We found out because the first mile you were going straight up until you got to this mountain. There, a little rock they had on the top of the mountain called Tongchungbang, which means where the peak meets the sky. And then the rest of it was run, but it was a mountain climb to begin with. But all along the whole thing, it was on the DMZ, but there was a lot of South Korean people watching the race. And every now and then somebody would yell, "Go Deke!" Okay. I found out they had a honky cheat list that said Deke is number 40. Yeah. Okay, another sorter. Here's a fancy, they did 2 of those. In Korea, you have to put $1 million worth of artwork in the building some way. And they put 2 of these out. And here's Ann Taylor in Louisville. And we started with dirt. I mean, this one started without anything. And we built the thing from ground up. And you can see, I think this is shipping. Yeah. Okay, I worked for IBM for about 3 years, and I went to one of their school. I went to school maybe 4 times. Lots of training with IBM, which is good. IBM was, as far as I'm concerned, the most moral company existing. Of course, people mess that up a bit, but very, very good company. I mean, their charter was really great. Okay, the last 20 years, I was a warehouse automation consultant, working for a company sometimes directly, but a lot of times working just as an independent consultant. And so what was I doing there? Well, uh, I worked on what we used to call best of class warehouse management systems, from like Manhattan DKMS, High Jump, DCMS, Red Prairie, like that. And half of the time, the last half, I was a functional engineer on Oracle WMS and RFs. Some of the last 20 years I spent as an employee, okay, for my own companies or for IBM, Equinox, Hitachi, and DAS. And then a lot of the times I worked for before firms I spent before the last 20 years were big firms were STS, Bunker Ramo, and Martin. I think we went through that. And then as an independent consultant, I had a batch, and this is only some of them. There was more. I've a lot of traveling. Okay, but the last 10 years, as I said, I was a functional consultant on Oracle WMS. And what do? I would design a layout of warehouse, create the operational warehouse by conducting design meetings, configuration of, you do a gap analysis, customization of design, software changes, and training of staff, and a lot of variety, because there are no two warehouses that are the same. Well, some close, but there's most of them change because of the product or because of their customer demands, or a lot or volume, or maybe some had need freezers and stuff like that. Okay, here's a couple of sites I was at. Helen of Troy, which is cosmetic, and here's a couple. I was with 15 Indians there, and that was a typical thing. 15, 16 Indians to me. You always need a honky to the warehouse because software communication is really important. And these guys spoke English, but they had pretty different accents. Okay, these two guys, Harsh, especially Harsh, and Karante, they were my buds. They were great. This is Devin here, Chandra, and I don't forget the guy's name. Uh, okay, hobbies. Well, along the way, you got to have hobbies to keep you fresh. I mean, even though you love your job and everything, and that's part of, I always felt my job was part of my hobby. But you got to have something a little different too. And I wouldn't really call it jumping on a plane's hobby because I only did it a couple times. And Harsh, that one guy, he went once with me. The other guys, they had a valid reason for not jumping. In El Paso, we were right near the border, and they were afraid they were going to get blown over the border and not be able to get back. And running, I ran 25, 30 years. And that was always good. And he ran a lot of 50 miles races, but this was only just a little marathon in Chicago. And as I got older, I don't run. I don't run now, but I hike, and I hike these trails, bike trails, and so forth. And I hike with my buddy, my dog, Black Lab, Cubby. Okay, courses I've taken during the last 20 years. Of course, there was the University of Phoenix. I got a BA in business administration, and that was good because they taught uh, to be able to teach in the University of Phoenix, you had to be employed in that industry or whatever you're teaching. And then, of course, the certificate in computer science at UCLA, and then a lot of Oracle ERP courses, including warehouse management, inventory, order management, and purchasing, and then other WMS related courses, including things like High Jump and Manhattan and so forth. Okay, and as I say, the last 20 years, I'm the independent automation consultant, and operated from Prescott. There's some Butte, but out of town a heck of a lot. There's a process control chart. Usually ended up generating those after we designed it. And as I had said before to y'all, every warehouse is discrete because product size, distribution requirements, demands, large, small, fashion driven, whatever. A lot of difference, and variety is important. Here's a they would this was at Quicksilver in California, Huntington Beach, and they would pick into the totes. Okay, they pick from like these flow charts. Okay, flow charts, these flow racks. Okay, or they'd pick really goods on hanger right from the rack, from those racks, and then they'd come to the packing station, and here they'd pack them into cartons and ship them off to shipping. Okay, and of course all this is automated and controlled, where barcodes lead you, and barcodes lead you to what order you're at, or what SKU you're picking, and all of that. Get a variety. I was in Rhode Island for American Cable, and on a 55-foot trailer, big trailer, you could only get 4 of these spools of cable on it because they were so heavy. You'd hit the 40,000 pound mark limit. Here's another flat sorter. You throw the goods into the sorter, and they Bombay open into whatever picking station they were destined to, their packing station. Here's in Dalton, Georgia, a company that provides all these little floor samples, whatever they are, rugs, linoleum, whatever. And if you go to Home Depot or whatever, and you see these little samples with little cutout thing, it's probably came from one of these Brown Industry plants. Here's California shoe company, and this is in Camarillo. This is one of the better warehouses. Believe me, this one's really automated well. Same plant. Here you're coming down from the top level down to the floor with the cartons. And here, same plant. You've got a station that does the labeling, okay? And so you got a number of different printers and so forth, and then you have different requirements. Well, every carton coming down that line has an identification, and you know what labels to put on it. It already has one label that then you read, and then you decide bap, whatever. And same plant, and you can see what they're doing down there. They're getting ready to palletize them for shipping. Now this is back at the wire company, American Wire, and this guy's Elmer. He worked for that company for like 42 years, something like that, and he was still working now. He probably still there. This is Shakespeare down in South Carolina, and packages, and you can see here's pretty uniqueness for them. These long tubes. Guess what goes in there? Yeah, fishing poles. This is down in Houston for NOV, and this forklift can lift 40,000 pounds. And they did Texas Towers, out there for a lot of big equipment, a lot of big, huge motors and pumps and all kinds of stuff. And a lot of their storage, even down in Houston, was outside. This is Brown Industries again, and this amazed me because this little section here cost $1 million. These rolls of flooring and rug and so forth were so heavy that this steel had to be really, really strong racking. And this is back in Camarillo, I think. Uh, this is in downtown Vernon, LA, for BCBG. And that's an operator, and she's happy. You can see people are working happy. This is Red Camp, Maryland, which is near Baltimore, Sephora. And inside Sephora is, you see these giant flags here? Sephora is owned by the French company, run by a lot of Chinese managers, believe it or not, in the United States. So this one French guy comes in and he's complaining about everything. He goes back to France. As soon as he's gone, Buddy, who's the manager, he gets these giant flags, American flags, hangs them all over the place.